Hello, my name is Roy Stewart. I'm from the Department of Information Science and Computer Technology. The other two researchers in this project is Karima Snow from the Department of Information Science and Computer Technology and Tamaz Emerson from the Department of Business Administration. Our project is titled An Observation of Prime Numbers. This study presents the results of our observations of prime numbers. A computer application was written in the C# programming language that calculates various prime numbers. The purpose of this study was to observe prime numbers, to identify and better understand patterns of prime numbers and their prime gaps. We hope to contribute to the body of knowledge in STEM and to review some of the pre-existing theorems and conjectures found within the literature. Why is this study important? Students enjoy the study of STEM, science, technology, engineering, and math. Prime numbers are the building blocks of all whole numbers. Every positive number on the number line can be written in terms of prime numbers. And prime numbers are used in public key encryption to keep the information safe on the World Wide Web. Although the topic of prime numbers has been extensively studied over the years, new and interesting facts still await to be discovered. There are two types of natural positive integers: prime numbers and composite numbers. Prime numbers are natural positive integers greater than 1 whose two divisors are 1 and the number itself. Composite numbers is the remaining natural positive integers on the number line that are not prime numbers. Prime gap, the gap between consecutive prime numbers, this gap is filled with composite numbers. For example, consecutive primes 3 and 5 have a prime gap of 2. 5 minus 3 equals 2. Therefore, 2 is the prime gap and it's filled with one composite number, 4. Twin primes. When the prime gap between two consecutive prime numbers is equal to 2, these two primes are considered twin primes. For example, the two consecutive primes 3 and 5 have a prime gap of 2. 5 minus 3 equals 2. Therefore, these two primes are considered twin primes. The first theorem that we're going to evaluate is that there are an infinite number of prime numbers. The second theorem we're investigating states that the size of the prime gap, or the width between two consecutive prime numbers, is random in length. Curtis also viewed the prime gap as a random gap between two consecutive numbers. Others observed that random gaps between the primes and noted that as the prime numbers increased in size, so too did the prime gap increase in size. Pirelli in 2003 supported the theorem of infinite primes, but indicated that if the prime gap had some pattern, the gaps could be used as a determinant of future prime numbers. Thus, large primes currently unknown could be forecasted based on patterns within the prime gap. So this study also reviewed the conjecture that there's an infinite number of twin primes. Zager in 1977 described twin primes as two consecutive prime numbers with a prime gap of 2 separated by only one composite number. So mathematically there, it's G equal P2 minus P1. For the methodology, the students helped create a C# application that generates a sequence of prime numbers. So after building the user interface, within the code, we also did data validation. To validate the input data, to ensure that the input data could be converted into a specific data type that can be stored in the local variables. So this study used a try-parse method for data validation. So it defined two variables, p and upper range, gave them both data type long, and then here's our data validation, long dot try-parse, and then the name of the text box low range dot text. So we got the text out of the text box, converted it into a long, and stored it into p. So we validated the data to make sure that it would be able to be converted. The study also used an if statement to validate the upper range and the lower range, p being the lower range. Okay. So we wanted to validate to ensure that the data runs from the smallest to largest, in other words, from the lower range to the upper range, as opposed to vice versa. And so there's our little example of our little if statement, or our if-else statement, to ensure that the data runs from the smallest to the largest. So tracking errors within the application. During and after data validation, the study sought to debug the application using exception handling. So the study used a try-catch statement to catch any exceptions that were thrown from any unexpected source. So this is our little try-catch. And so we tried, and of course there's not enough space here to put in the full code from the try, but it is in the full paper if you want to go back and look at the full paper, which I hope you do, and you can see what was located within the try. Our data validation was located within the try, but here's our little catch for it. It's a little exception catch. Come up with a message box. It gave us the error message and a stack trace, so we could find out exactly where the message was located, and we put a little data error to the end user, and we put the buttons and icon for the message box out there, so that we practiced using the 4 parts of message box. Okay, we also outputted data to an output file. So this study used a StreamWriter to append an output file named primenumbers.txt. The while loop was used to write either a prime number, so if it comes back from ISPRIME as being a prime number, write out the prime number, also wrote it out as bold. If it come back as not a prime number, in other words the else, then it printed out just a dot in bolds, so that we get a number line with prime numbers and dots in between the prime numbers to represent non-prime numbers. So the output file was closed after outputting all the data to a text file. And so we also have an exit button on our application. So application.exit gives the application the ability to close any unclosed threads and allows any threads to release unreleased resources prior to exiting the application. So we'll put in there application.exit, and of course we only had one form, so we could have put this.close, but we put application.exit because the next thing that we're going to do in our class was to make multi-forms. So this is in preparation of making a multi-form application. So this is the piece of the application code. We constructed a brute force method to determine if a number is prime. For example, if p equal 3, then 3 divided by 2 equal 1.5. Okay. there's a remainder. Therefore, 3 modulus 2 exactly equal to 0 will not be true, and will continue throughout the for loop until all the iterations are finished, and then we'll return a true that 3 is a prime number. Another example, if p equal 4, then 4 divided by 2 equal 2.0, no remainder, and will not have a remainder. Therefore, 4 modulus 2 exactly equal to 0 will be evaluated as true and will then return a false. Therefore, 4 is not a prime number. After reviewing a whole bunch of prime numbers, Figure 2 shows that the quantity of primes first started declining. At the 100,000 mark, the count remained relatively stable from that point on, at about 6 primes for every 100 integers at the range 100,000 to 100,100. These results support the theorem that there are an infinite number of twin primes. We also reviewed the conjecture that there's an infinite number of twin primes. The first twin prime occurred between primes 3 and 5. Other twin primes were identified throughout the study, and the last twin prime occurred at 1,000,000,007 and 1,000,000,009. These findings support the conjecture that there's an infinite number of twin primes. After reviewing thousands of prime gaps looking for patterns within the prime gap, no patterns were found. Supporting theorem 2, that the prime gap between 2 consecutive prime numbers is random in length. The research did, however, discover an interesting prime gap. The prime gap of 10, we named it the HSSU diversity gap, is the only prime gap that has a diverse number of composite numbers, 9 to be exact. All prime gaps prior to prime number 149 contained a prime number of composite numbers that filled the gap. The HSSU diversity gap is the first such gap that contains a composite number of composite numbers that fill the prime gap. Further review of prime numbers found that the HSSU diversity gap occurred 16 times within the first 1,000 positive integers on the number line and appears to have an infinite number of occurrences. Since we did not find any mention of the significance of the prime gap of 10, the HSSU diversity gap, in the literature review, we assume that this new discovery does in fact add to the STEM body of knowledge. Closing and interesting future thoughts, it may be interesting for future research to look at patterns within the data of larger prime numbers, since large prime numbers appear more stable. Therefore, larger numbers may yet reveal patterns within the data, which could allow for forecasting of prime numbers. Future research may also include evaluating different types of methods for factor analyzing integers based on the method's effectiveness and efficiency. Once prime numbers can be accurately forecasted and numbers can be effectively and efficiently factor analyzed, it should be easier to build more secure cryptographic algorithms for cybersecurity.
We hope you enjoyed our presentation. Conducting this research.
Thank you for watching our presentation, and we want to thank Harris-Stowe State University for allowing us to use their name and logo in our research. and included here is a list of some of the sources that we've used for our literature review. Again, we want to thank you very much for watching our presentation.